And I wanted to ask you about people with whom you've worked, including Warren Saws. I know that you have done writing and editing with other people. Are there any particular associates that you'd like to point to?
Certainly a lot of people, and let's just talk about Nebraska because
all right.
we're
Nebraska.
talking about the Nebraska program, but there are a lot of colleagues I interact with in other places too. The program has gone for a long time here, starting with rotation work back in the 30s, 40s, 50s. There's been a lot of good, solid physiology go on. The soils people, I think, were particularly instrumental in starting a lot of our concern about sustainability. Prof. Olson, the late Robert Olson, was active in doing the soil test laboratory comparisons in the 70s, early 80s, and those were widely publicized. I think were very influential in the way we look at the whole soil testing activity. And the current generation of soils people, Don Sander, Dick Weiss, Ed Peñas, Charles Shapiro, Richard Ferguson, a new generation of people are coming along, again, validating much of that information, looking for crop response models, data sets, to calibrate their current algorithm or approach to setting soil test interpretations and interpreting those, finding ways to budget nitrogen in the entire cropping environment so that we, in fact, put on what is needed in a given situation rather than over-applying or under-applying. In the past, we have, in general, over-applied, and that's why we have such a nitrate problem up and down the Platte Valley. It's been cheaper for us in the short run to apply extra, to not worry about it, and not worry about the long-term consequences beyond the farm. Our weed management people, and I say management very carefully, that's management, not control. We're looking for ways to manage these biological populations of weeds in ways that are compatible with reducing production costs, compatible with not putting any other chemicals into the environment that are not absolutely necessary, monitoring where those chemicals go after they hit the leaves, after they hit the soil. Do they in fact turn into benign compounds? Do they in fact go down through into the groundwater? What happens? Fates of pesticides. So the crop protection folks, entomologists, as well as the weed management folks have been doing a lot here in Nebraska. And I think putting a lot of this together in terms of tillage, in terms of crop management, looking at hybrid and variety choice, we've done quite a bit over the last decade or so, looking for ways, again, to look at the total picture, not just the maximum yield, perhaps not even the maximum short-term economic yield for a given season, but rather the sustainable productivity of a farm. This leads us, of course, back to many rotation-type studies, many more long-term studies, looking at the contributions of legumes, the way crops can sequence in the field, and how we put together appropriate sequences versus those that are not as appropriate to squeeze the maximum out of that biological potential, out of those cycles of nutrients that are very important. All of this is part of our history here. It's coming together now in the last few years under what's being called sustainable agriculture. The Center for Sustainable Agricultural Systems will, in fact, further that work by the various people, not just in agronomy, but in biological systems engineering, animal science, ag economics, horticulture. We think there's a lot to be done in the urban scene. There's great concern, I think, about the amount of pesticide, the amount of fertilizer that are applied to home gardens, lawns, often with very little experience, very little formal training.
Not even reading the label, I'm sure, sometimes.
Well, unfortunately not. I think our farmers are far better prepared, far better understand the implications of chemical use than a lot of urban folks. As you say, we're too busy to read the labels, and someone says it'll do a job, or we hear that it will, and we go out and try it, and maybe double the dose if we want to be twice as sure. And we have to stop these kinds of activities somehow.
And education, we come back to education, and the more we can get people aware of what's really needed and what's going on. What's going on here at the University of Nebraska is really exciting. It's been going on for a long time, not called particularly sustainable agriculture, but interest and work on research in these areas. Two things impressed me: the fact that you're talking about long-term research. You're not talking about something that you put in the field one year and check it out the next year and put it on the market, or say it's not okay for the market the next year. You're talking about years of checking and going back to plots to look at.
We are. It's a long-term process, but I would quickly say that we're looking for other strategies outside of the current research paradigm that does say, yes, we need 5 years of data, or yes, we need long-term small plot research. And we get clues from commercial industry on this. Certainly hybrid corn companies don't test a new hybrid for 5 years, because if they were to do that, that hybrid would then be at the back in the pack somewhere, and there'd be much better material coming along, if not from their own program, from their competitors. Commercial companies test their materials in many locations in a single year or a couple of years, and if they know the parents well, they feel comfortable to go ahead and sell that new corn or sorghum hybrid. We think we can, in fact, substitute locations or sites for years in a very effective way. And you think of our major constraints here in Nebraska, what really varies from year to year. For us, it's rainfall. And we can, in fact, simulate those differences that occur on a given farm over a number of years by going to a number of different sites that have less rainfall or more. We can get probably as much variation if we have enough sites in a given year as we can over 10 years, for example, on the same site. So that's a way to quicken the research process, make it more efficient, more cost-effective. Another way is to work more closely with farmers, and we're very excited about participatory research approaches such as those used by the Practical Farmers of Iowa, by our own Nebraska Sustainable Ag Society. Farmers have a lot to bring to the table. Farmers have tremendous interests, they have resources, they are the ones who are ultimately going to use this technology. Most important of all, they have many ideas, because they're out there all the time testing new things. We did kind of a cutesy estimate a few years ago and made some slides on this that said, well, if each farmer tries 10 new things each year, and I think that's a very conservative estimate when you consider the fact that farmers are changing hybrids, they're modifying their fertilizer rates, they're perhaps adjusting row width, buying a new planter perhaps, doing some ridge tillage. Farmers are trying new things all the time. But if we conservatively say that each farmer does 10 things that are different each year and somehow evaluates the results of those, and if we have 60,000 farmers in Nebraska, that's 600,000 experiments, in quotes, each year, or trials or tests. Now, if every researcher in Nebraska, and I think we have around 300 research people, public, private, and so on, if each of those people do 100 experiments per year, and I think that's a very liberal estimate, you can multiply that out. Farmers are still doing 20 times more research than researchers are. Now, what is research? Obviously, farmers are doing things in a different way. They're following a different model. The farmers we talk to like to compare last year with this year. This field with the one across the road, or a field across a fence line. They're not methods that we would consider, from a research standpoint, statistically valid, yet when you see things that are different, if they're grossly different, you believe those differences if you've done them yourself. There's nothing wrong with that, certainly. It's a very real experience. Farmers like to see large fields. They like to make minor modifications in their system that are not too costly. They like to see something that's cost-effective coming out as a result of this experiment. Those are all characteristics that farmers put credence in. They like something that's done very close to home or on their own farm. Now, what do researchers like? Researchers like small plots because they have control over more of the variability in that area. They like a number of treatments that are quite similar. Corn hybrids that may be genetically different but are similar in height, so that you don't confound the differences in reaction.
Skew the results.
Just to the height alone. Researchers insist on replication and randomization of the treatments. All of these allow us to use current statistical methods to analyze our results, to publish them in journals, and so on. We believe those results, we as researchers. We as farmers sometimes question those results because they came off of garden plots, they came off of highly controlled areas, perhaps they were irrigated, and my farm is on dry land, and so on. So what we have is a whole series of criteria here that farmers believe, another series of criteria that researchers believe, and sometimes they don't believe each other. Often they do, of course, but for purpose of argument, they're coming at it from a very different standpoint. Now, what the Practical Farmers of Iowa, our Nebraska Sustainable Ag Society, our farmer collaborators are doing is studying what researchers do. We as researchers are studying what they do. We're looking for ways to rationalize these differences so we can, in fact, do joint activities that meet all of our criteria, that we're both satisfied with. And this takes some interesting forms. Generally, it means long drive-through plots that are all the way across a quarter section, perhaps. They may be 1,200–1,300 feet long. They're usually 1 planter width wide or 2 planter widths wide, so you can drive down the field.
That's
and
what
back
you meant
again.
by drive-through?
Drive-through, yeah. Drive from one end of the field to the other, not have to stop every 30 or 50 feet, change treatments. So we're looking at ways to analyze these large-scale experiments that are replicated, that are randomized, and run our standard statistical analyses to see how credible these are. In fact, in analyzing results from on-farm activities in both Iowa and Nebraska, we found that these are very precise when you go across a long distance of field. We didn't know at first why they were precise. We still don't for sure, but we're quite convinced that the fact that we go across a lot of field variability, there's probably more variability from here to the other end of the field than there is from one plot to the next when they're side by side. So this is an integration of all that variability. That's a very nice comparison between those two treatments. So it's just an example of how we can use large plots, use full-sized equipment, use things that farmers design, and then analyze these results in a way that we find statistically meaningful, that fits the criteria of repeatability from our statistical standpoint.